Okay, so same continuing the exercise 6.2 and 13th question. He has given four options to check on which interval this function is strictly decreasing. So when we differentiate this, we'll get 100 x to the power of 99 plus cos x. So now we can check any value you give between 0 and 1. This is positive. For this also, this is positive. So for this also, this is positive. Therefore, it is this entire thing is greater than 0 for A, B, and C intervals. Therefore, D is the correct answer. Next question is find the least value of A. That means there may be many values for A such that x square plus ax plus 1 is strictly increasing on this interval. So we do f dash x, we get 2x plus a, differentiation of this. So it should be strictly increasing. That means 2x plus a must be greater than 0. So we need to get a values within this interval. So we'll give something more than 1 for x. So let x equal to 1.5 and x equal to 1.9. Some two values between them. So for this x equal to 1.5, you will have 3 plus a must be greater than 0. That means a must be greater than minus 3. For this, 3.8 plus a must be greater than 0. So a is greater than minus 3.8. So you have now two values. One is minus 3 and the other one is minus 3.8 on the number line. So which is the least value? So least value is this. This is greater than this. Therefore, it should be minus 3.8, or better, you can actually substitute x equal to 2. When I substitute x equal to 2, then I got 4 plus a is greater than 0. So a is greater than minus 4. So minus 4 is the least value. So minus 4 corresponding to this 2. That's how we get the answer. So least value is minus 4. Okay. Next question, 15. I is an interval disjoint from minus 1, minus 1. So there is one interval. So excluding this, there is another interval I. That is what we need to, on this interval, prove that prove that f of x that's equal to x plus 1 by x is strictly increasing. That means any other value that you can give 0, minus 1, 1, except this interval. Any other values you can give, and we have to prove that this is strictly increasing. So what we have to do for that, differentiate first f dash x equal to 1, and for this it's minus 1 by x square. So let's try f dash minus 2, which is outside this. So you will get 1 minus 1 divided by 4. That's equal to 3 by 4. Let's give f dash 2. That's equal to 1 minus 1 by 4. That's equal to 3 by 4 as well. In fact, whatever you can say that for any value of x outside this interval minus 1, 1, the second term 1 by x square is less than 1 and greater than 0, which is a fraction, a proper fraction. So a proper fraction which is less than 1. That implies that 1 minus any proper fraction, a proper fraction, Proper fraction meaning numerator is less than the denominator. So we'll give you another proper fraction. This is greater than 0. So that implies f dash x is greater than 0 for all x outside -1 and 1. Therefore, strictly increasing f of x is strictly increasing over interval I. I is the interval anything other than -1, 1. Okay. So 15th we have done. We have 4 more questions in this exercise. After that we'll be starting another topic, tangents and normals. Very important one. So 16th question. So function is f of x is equal to log sin x. F of x equal to log sin x. And he wants us to prove that this is strictly increasing in this interval 0 to pi by 2 and strictly decreasing in the interval pi by 2 to pi. This is what we need to prove. Prove this is strictly increasing like that. So f dash x equal to 1 by sin x, then chain rule. For sin x, differentiation is cos x. So we have cot x. Now we have to give these values. So we can have a table. So any values, f dash x value, and then say 30 degrees, 60 degrees, or even 45 degrees you can take instead of 60 degrees. So 45 degrees. And then this one is the second interval. This interval is between 0 to pi by 2. And further intervals are 90 over 90 it should be, let's say it's 120 degrees and 150 degrees. Like that. This interval is between pi by 2 to pi. So I'm making a table kind of a thing. So I'll see f dash x value. So when I give 30 degrees, that is cot 30. Cot 30 is nothing but root 3. And 45 degrees, that means cot 45 is 1. 120, so that is in this. So in this, only sign is positive. 120 degrees and 150 degrees. This 120 and this 150 degrees. So both are negative. This is negative, this is negative. Okay. So from the table, we infer f dash x is greater than 0 in the interval 0 to pi by 2. Therefore, strictly increasing. And f dash x is less than 0 in the interval pi by 2 to pi. So therefore, strictly decreasing. Proved. So we will come to the next part of this page, and that's the 17th question. So the same thing we have to prove the other way around for f of x log cos x. F of x log cos x strictly decreasing over 0 to pi by 2, strictly increasing over pi by 2 to pi. So f dash x equal to 1 by cos x multiplied by minus sin x chain rule. So that's equal to minus tan x. So we make the same table, 30 degrees, 45 degrees, and 120 degrees, 150 degrees. So this is for pi by 2 to pi, and this one is 0 to pi by 2. So f dash x value, which is minus tan x, that means this is minus tan 30. So in both the cases, minus tan 30 here, and this is minus tan 45, which is minus 1 by root 3, and this is minus 1. So this is negative. 1 second, I'm getting a call. I just quickly answer the call. Hello, good evening. Sorry, are you a student or? Okay, I'm in tuition. You can call me later in the night, okay, after 8:30. No, we don't have any vacancy. Okay, by the way, I don't have vacancy. Right? So, okay. Sorry, Stan. So, and in this, tan is negative, so minus tan will be, this is positive value, this is positive value. So both are positive. So that infers that f dash x is less than 0 in the interval 0 to pi by 2 and greater than 0 in the interval pi by 2 to pi. Therefore, f of x is strictly increasing, strictly decreasing in 0 to pi by 2, strictly increasing over pi by 2 to pi. Understood, right? Hope you understood. So just want to make sure that you are there. Yeah, it's there. I'm doing
Can
the.
hear me, sir.
Yeah, I can hear you. There is a delay. I understood. I understood. Last time you told me. 18%. 18th question. So prove that the function given by f of x equal to x cube minus 3x squared plus 3x minus 100 is increasing on R. R means all real numbers. So first one, f dash x. F dash x equal to 3x squared minus 3x plus 3. So this is what he's asking. And to take 3 common, you will have x squared minus x plus 1. So this is a kind of function what we have. So if you give x equal to 0, for example, or x equal to 1, whatever, okay, so depending on what values you give, so that is why what we do is we do completing the squares for this in order to get this. So when we do the completing squares, we can actually plot the graph. Otherwise, you'll have to give negative values, positive values, and then you have to do. Even that also you can do. So let's suppose we give some different values like minus 2, minus 1, this is x value, and this is dash x value. So 0, 1, 2, 3. You can do this way also. So f dash minus 2, that means 4 plus 2, 6 plus 1, 7, 21 you get. Minus 1, then this is plus 1, and this is plus 1, and plus 1. So 3 times 3, 9. When you give 0, it is 3. When you give 1, it is 3. Because 1 minus 1, 0, 3 times 3. 0 also 3, 1 also 3. Then you give 2, 4 minus 1, which is 3, 3 plus 1, which is 4, 4 times 3, which is 12. You give 3, then you have 9, 9 plus 1, 10, 10 minus 3, 7, 7 3 is 21. See, it is going only to something like this, 21, 9 and all, but still for all the things it is greater than 0. Okay? So for which value, if at all it becomes 0 or negative or anything, so for negative, it's impossible because you've got x squared minus x. And therefore, this is increasing in the interval all the intervals forever, whatever you take. Uh, so since f dash x is greater than f dash x is greater than 0, okay, for x belonging to R, f of x is increasing. So let me tell on the completing square method also. So sometimes that is also useful. So x squared minus the other method to prove f dash x is greater than 0 is x squared minus x plus 1 can be written as, when we divide this by 2, we will have half. So x minus half whole squared, that means you are dividing this by 2. So then I'll have minus x minus half whole squared. So you have plus 1 by 4. So after that you will have plus 3 by 4. You will have plus 3 by 4. If you add 1 by 4, you will get from here, and 1 by 4 plus 3 by 4 you will get as a 1, and this x squared minus 2x. This can be written as this in the completing the squares method. So when we do this, it is an equation of a parabola in such a way that the point is half and minus 3 by 4. So the lowest value it can go is when you give half, that's equal to half, and this is minus 3 by 4. Let us check this value. When I have x squared minus x plus 1, and let's say x is equal to half, then I'll have 1 by 4 minus 1 by 2 plus 1, which is, if you take LCM also, 4, 1, then minus 2, and 2 times 2 is 4, and plus 4. So 5 minus 4, it's 1 by 4. Am I doing it correct? So 4 is 1, and 2 is 2, minus 2, and this is 5 minus 2 is 3 by 4. So it's plus 3 by 4, x equal to half, plus 3 by 4. So this is not a correct graph. So you have half and 3 by 4 as a vertex. That means the graph will be like that. So this is the half and this is the 3 by 4. So since the graph is above x-axis, so since f of x, f dash x is greater than 0 or above x-axis for all values, so f of x is increasing. That's what we can input that. So that completes the question 17. Sorry, question 18. This is 18. We have done the 18th question. 19th question is a multiple choice. Question number 19. Interval in which we have to find the interval in which y is equal to x squared e power minus x is increasing. And he has given 4 choices. First choice, A, is minus infinity to infinity. That means the entire thing. Okay. B, so minus 2 comma 0. C, 2 comma infinity. And D, 0 comma 2. So we need to find out increasing. Okay. So that's why this is a product rule. Y dash we want to do. So u dash v. So this is u dash in e power minus x plus u v dash. V dash is minus 1 into e power minus x. So what we have is e power minus x. If you take out common, then you have 2x minus x squared. So this is a function what we have as a y dash. So now look at different things. So even from x also you can take off common. That also you can do x e power minus x. Then you have 2 minus x. So if you give e power minus x will be like this. E power x will be its increasing function, keeps on increasing like this. This is e power x. E power minus x will be like this. So this is e power minus x. So e power minus x is anyway positive for all values of x. And here, if you give x much higher value, say for example 10,000 or something like that, x is equal to 10,000. Let's say x is equal to 100. Then what happens? Y dash equal to 100 e power minus 100 to 2 minus 100. So that becomes, this is minus 98. So minus 9800 e power minus 100. Definitely a negative value. So y dash is becoming negative. What does it mean? So for some values it is positive, for some values it is negative. So since y dash is, this is for infinity to plus infinity. That's why we can't actually judge immediately. This is the answer. Okay, let's go back to the other intervals. This we have seen for minus infinity to infinity. So if I give 0 to 2, for example, 0 to 2, this is any, yeah, this is positive, this is positive, and this is also positive. Therefore, it is increasing over the d. 0 to 2 y dash is greater than 0. Therefore, d is the correct answer. 2 to infinity, not correct. Minus 2 to 0. If I give minus 1, for example, positive, minus 1 to 0. 0, we have, let me see, why not minus 2 to 0? Is it 0 to 2 or minus 2 to 0? If I give minus 1, minus 2 to 0. So looks like minus 2 to 0 is actually B is the better answer. And let me check that. 6.2, right? 6.2. No, you are correct. D is the correct answer. D is the correct answer. Because B, when you take minus 2, this fellow is minus, no? Here this fellow is minus, and therefore not correct. Okay, so up to 19 we have done. So the exercise, before I go to exercise 6.3, I'll have to explain about tangents, normals, and all the things. Tangents, normals. So here what happens is f of x will be given. F of x will be given. F of x is nothing but f of x can be a curve. So if it is a curve, then for example, f of x is something like a curve like this f of x. Then definitely for some value, at some value of x, you can draw a tangent to this. This is a tangent. So tangent, the moment we say it's a tangent, both tangents as well as a normal, both are a straight line. If it is a straight line will have an equation. So we know the straight line equation is y is equal to mx plus c form. So in this, if we are talking about a tangent, then this m is nothing but dy by dx of the curve, or f dash. So if I have, for example, x equal to say 3 here, then you do the f dash x, f dash 3 will give you the slope of this tangent. So that is what is the important thing. Let us suppose we already found the tangent equation, and let's say m1 is the slope of tangent, m2 is the slope of normal. What is normal? Normal is exactly perpendicular to this. This is normal. It can be down way also, this way also. So normal is perpendicular. Therefore, if both are perpendicular, m1 multiplied by m2 is equal to minus 1. We use this rule in this exercise. If you find m1, then m2 is equal to minus 1 by m1. So then you get the equation of the tangent, equation of the normal, y normal. I call this as a y tangent. Y normal is equal to m2x plus c. That's equal to minus 1 by m1 into x plus c. So finding the slopes, which means differentiation of the curve, and getting the equations of the normal and the tangent. That's all this entire exercise is about. So
Okay, sir.
I'm going with the first question in exercise 6.3. So the first question is find the slope, exercise 6.2, question number 1. Find the slope of the tangent. Find slope of the tangent to the curve to y is equal to 3x to the power of 4 minus 4x at, this is important, at x equal to 4. That means you differentiate first and substitute x equal to 4. So dy by dx, we do dy by dx. This is nothing but the slope equal to 4 into 3x to the power of 4, 3x cube minus 4. That's equal to 12x cube minus 4. So we write now dy by dx at x equal to 4, or slope at x equal to 4 equal to, substituting 4, 12 into 4 cube minus 4. This is 64 multiplied by 12. 12 64s are 12 4s are 48. 12 6 are 72 plus 4 768. 72 plus 4 768 minus 4, so 764. That's the answer. Second
Okay,
question.
sir.
Find the slope of the tangent to the curve y is equal to x minus 1 divided by x minus 2 at x equal to 10. So second question, y equal to x minus 1 divided by x minus 2, slope at x equal to 10, how much? Differentiation, so we need to use the u by v rule. So dy by dx equal to x minus 2 whole squared, and u dash v, u dash is 1, v is x minus 2 minus 1. So x minus 2 minus 1. So you will have minus 1 divided by x minus 2 whole square. Because x gets cancelled, then you have minus 2 plus 1 is minus 1. So dy by dx at x equal to 10 equal to minus 1 divided by 10 minus 2 whole square. That is minus 1 by 64. So that's the slope. The third one, find the slope of the tangent at the point whose x coordinate is 2. So we need actually x coordinate is 2 only, we don't need a y coordinate. So third one is y is x cube minus x plus 1. So we need to find dy by dx at x is equal to 2. So 3x squared minus 1 is dy by dx. So dy by dx at x equal to 2 equal to 3 into 4 minus 1, this is 11. So fourth question, find the slope of the turn. I think that's easy, straightforward. I'm skipping fourth one. I'm doing the fifth
Sir.
one. Yeah, I'm doing the fifth one. Fifth question is find the slope of the normal. So find slope of normal to the curve. This is a good question. So x is equal to a cos cube theta and y is equal to a sine cube theta at theta equal to pi by 4. Theta equal to pi by 4. So we need to find out slope of tangent first we need to find out, and we call that as probably m tangent, we can call it. That's equal to dy by dx, but this is all in theta, so that's equal to dy by d theta divided by dx by d theta, then substitute at theta equal to pi by 4. So dy by d theta is nothing but this one, a into 3 sine square theta, and chain rule for sine theta, it is cos theta. So we have 3a sine square theta cos theta. So then dx by d theta equal to 3a cos square theta into minus sine theta. So minus 3a sine theta cos square theta. So this is what we have. Dy by dx equal to this divided by this. Therefore 3a sine square theta cos theta divided by minus 3a sine theta cos square theta. So you will have this gone with this gone, this gone, this gone. So you will have a gone, 3a gone. So you will have minus tan theta as a final divided by dx. So this is nothing but our mt is dy by dx. That means tangent slope is minus tan pi by 4, because it's at pi by 4. That's equal to minus 1. We want to find out m normal. M normal, so that's equal to mn. But we know slope of tangent multiplied by slope of normal is equal to minus 1. So slope of normal is equal to minus 1 by mt. That's equal to minus 1 divided by minus 1. It's equal to 1. So slope of the normal is 1. That's the answer. This is the answer. Okay. Then we go to the next part of it. So So you have a similar question, sixth one, but I am doing it also. Sixth question is find the slope of the normal to the curve. Find the slope of the normal to the curve. That means we need to find m normal, slope of normal, x equal to 1 minus a sine theta, and y equal to b cos square theta at theta equals pi by 2. Similar method, similar procedure. We do first dx by d theta or dy by d theta. That's equal to dx by d theta is 0 minus a cos theta. That is minus a cos theta. Dy by d theta equal to b into 2 cos theta into minus sine theta. So this is minus 2b sine theta cos theta. So dy by dx equal to minus 2b sine theta cos theta, that is this one, divided by minus a cos theta. So cos theta gets cancelled, minus gets cancelled, and that's equal to 2b by a. So this is dy by dx. So, sorry, 2b by a sine theta, without sine theta. So dy by dx is nothing but slope of the tangent, that's equal to 2b by a sine theta. And when theta equal to pi by 2, that's equal to 2v by a into sine pi by 2, which is 1, therefore 2v by a. So this is the slope of the tangent, mt at theta equal to pi by 2 is 2v by a. So that slope of normal, which is, let's say, mn equal to minus 1 by mt. That's equal to minus 1 by 2v by a. So that's equal to minus a by 2v. That's the answer. So we have completed the 6th question also. 7th question, we need to find the points at which the tangent to a particular curve is parallel to x-axis. This is a condition is there, and we need to find the coordinates of the point. That's what this particular question is. So let's get the separation. Question 7. So the y is x cubed minus 3x squared minus 9x plus 7. So find the points at which tangent to above curve is parallel to x-axis. So the point here is, this is the keyword, parallel to x-axis. If something is parallel to x-axis, that means its slope is 0. This means the slope is 0. Okay? Means slope of the tangent is 0. So we need to first differentiate that y dash equal to 3x squared minus 6x minus 9. So this is y dash, and this is the slope. And he said it has to be 0. Y dash is equated to 0. For the tangent to be parallel to x-axis. That means we are solving this quadratic equation. So we have 3x squared minus 6x minus 9 equal to 0. So take out 3, we'll have x squared minus 2x minus 3 equal to 0. Then, when we factorize this, we'll have x minus 3 into x plus 1 as a factor. So these 2 points, definitely the slope is 0. That's why it says find the points at which this is parallel. So this will be 0, implies x equal to 3 or x equal to minus 1. So for these points, y dash is 0. So we need to find points mean coordinates. So our y is nothing but x cubed minus 3x squared. Here is the original curve, minus 9x plus 7. We are trying to get the y coordinate. So when x equal to 3, what's the y coordinate? So y is equal to 3 cubed minus 3 into 3 squared minus 9 into 3 plus 7. That's equal to this 3 cubed, this 3 cubed get cancelled. Minus 20 is what we get. Y is equal to minus 20. So one point is 3 comma 20 is one point. So we need to find the other point. For that, we need to substitute x equal to minus 1. Y is equal to minus 1 whole cube, minus 3 into minus 1 whole square, minus 9 into minus 1 plus 7. So this will give you minus 1, minus 3 plus 9 plus 7. So 16 minus 4 is 12. So the second point is minus 1 comma 12. This is the second point. That's it. We found 2 points. This is one answer, part of the answer, and the other one is the other part of the answer. So this kind of questions, like we need to find the y coordinate also. It's not just the x value. Okay. Eighth question. Find a point on the curve at which the tangent is parallel to the chord joining the points. So this is kind of a slightly twisted question, but I'm doing it in the next page. So question number 8. I write the question because it's a little lengthy one. Find a point on y is equal to x minus 2 whole squared at which the tangent is parallel to the chord joining So chords can be even for the curves, not necessarily in the circle only. So 2, 0 and 4. So that means, how do I get, so there is, for example, there is a curve like that, and there is a chord like that. This is a chord. So he wants us to find out this tangent. Maybe this is parallel to this, for example. Then he is saying that a point, that means this point is the one we need to be finding out. So he has given 2 points. This one point is this, other point is this point. So first thing what we are doing is slope of tangent equal to slope of the chord. That means dy by dx equal to slope of the chord. So slope of the chord is y2 minus y1 divided by x2 minus x1. So yes, y2 minus y1 is 4 minus 0 divided by 4 minus 2. That's equal to 4 by 2, this is 2. But we have to differentiate left side. So differentiation of that would be dy by dx is actually, but dy by dx is 2 into x minus 2. So this is what dy by dx. So this is equal to, therefore, 2 into x minus 2 equals 2. So this is on the right side. This 2 is this. dy by dx is this, and this is the left side. So 2 gets cancelled, and we are left with 1. So x minus 2 equal to 1. That implies x equal to 3. So after doing that, read the question always. Did he ask a find a point or find many points? So if you look at the question here, find a point. He said find 1 point only. That means you have got only one value of x. So this is x equal to 3. So in order to find a point, we need to find y value at x equal to 3. How much? So y is equal to x minus 2 whole square. That means 3 minus 2 whole square. This is 1 square. This is 1. Therefore, 3 comma 1 is the required point. Okay, sir. Okay. So we have completed the first page of that 6.3, and we are going to the next page. Question number 9 and all on the next page. We have almost 25 questions in this exercise, which is a lengthy one. So I'm going ahead with the 9th one. I'll do as many as possible. Okay. 9th question. We do have time, but we'll have up to 5:45. Okay. Yes, sir. 9th question is find point on the curve. Pretty much similar. So we have y is equal to x cubed minus 11x plus 5. In this case, it's at which the tangent is y is equal to. So he has given the tangent equation. Tangent is y is equal to x minus 11. That means the slope of this tangent is 1. So So slope of tangent is 1. How did I get? Because y is equal to mx plus c compared with. So this is this m. So that's why you get function. So when I do dy by dx equal to 3x squared minus 11. So equate this to this. Therefore, 3x squared minus 11 equal to 1. 3x squared equal to 12. That implies x squared equal to 4. X equal to plus or minus 2. So again, looking at the question, he says find the point. For this, the tangent is this. So he's asking only a 1 point, not 2 points. Let us look at this. Why it can't be 2 points? Because let's suppose x equal to 1, then y value for 1 for 2 x equal to 2, 2 cubed minus 11 into 2 plus 5, that's equal to 8 minus 22, 8 plus 5 minus 22. So 13 minus 22, this is minus 9. So we'll have 2 comma minus 9 is 1 point. The other point is y is equal to minus 2 whole cube minus 11 into minus 2 plus 5. So this is minus 8 plus 22 plus 5. 27 minus 8, this is 19. So the other one is minus 2 minus 19. So these are 2 points. So why we are stopping at maybe 1 point? So we need to be checking whether both are possible or not. Okay? So our equation is y is equal to x minus 11. Y is equal to x minus 11 is the tangent. So let's suppose I substitute 2 here. When I substitute x equal to 2, then y is equal to 2 minus 11, therefore minus 9 is working. So I substitute minus 2 here. So y is equal to minus 2 minus 11. So I'm getting 13 minus 13. So this is invalid. Let's check this one more time. So we have got actual is x cubed minus 11x plus 5. So when I substitute minus 2, then I have got minus 8. Minus 2 into minus 11. This is equal to plus 22 and plus 5. 27 minus 8. 27 minus 8 is 19. So minus 2 minus 19. Minus 2 minus 19 is not a point on this tangent. Therefore, your answer is this is the correct answer. This is a valid point. And this is what is required. This is not on the tangent. So 10th question. 10th question is find the equation of all lines. So now starting with the equation. The moment they say equation, then we have to get into this form of y is equal to mx plus c. So not only finding slope, we need to get the equation. That means we need to see the y-intercept and other things. So the question is find equation of all lines having slope minus 1, having slope minus 1 and minus 1 that are tangents to the curve, that are tangents to the curve y is equal to 1 by x minus 1. So there will be many lines. That's what he means to say. So let us see how we will get it. So first one, dy by dx. That's equal to minus 1 by x minus 1 whole square. By applying whatever formula, you can do u by v, you will get minus 1 by x minus 1 whole square. So this is what it is. But slope is given to be minus 1. That means we have to equate this, which implies that minus 1 by x minus 1 whole square equal to minus 1. So this gets cancelled. So you will have x minus 1 whole square equal to 1. So x minus 1 whole square equal to 1 is the condition I'm getting it. So when I solve it, x minus 1 equal to square root of this. That means plus or minus 1. So 2 points, x equal to x minus 1 is equal to 1 or x minus 1 is equal to minus 1. And when I have x minus 1 is equal to 1, this gives me x equal to 2 and this gives me x is equal to 0. So one of them has x equal to 1, other one x equal to 0. So if I have x equal to 2, so y is equal to, so for example, I have x equal to 2, then I need to have the equation of all the lines having a slope minus 1. And what did I do? That means just go back. I have equation of the lines having slope minus 1 that are tangents to this curve. Tangent to the curve is this. Slope is minus 1. So I equated this slope minus 1 and then I got x equal to 2 or x equal to 0. So x equal to 1 and x equal to 0. How can they be the lines? But then we need to get minus something. Slope is to be minus something. So let's assume that since slope y is equal to mx plus c is the equation of tangent, in this case y is equal to minus x plus c since slope is minus 1 and we equated the condition for slope minus 1, x is to be 2 or x equal to 0. So when x equal to 2, y is equal to, so y is equal to 1 by x minus 1. So when x equal to 2, y is equal to 1, x equal to 0, y is equal to minus 1. So the 2 points are 2 comma 1 and 0 comma minus 1. So these 2 points we need to check with this. So let's suppose I substitute 2 comma 1. That means 1 equal to minus 2 plus c. That implies c is equal to 3. And I substitute this. Minus 1 is equal to 0 plus c. So c is equal to minus 1. So I have 2 lines. One line is c3, other line is the c equal to minus 1. Therefore, based on this, y is equal to minus x plus 3 or y is equal to minus x minus 1. These two are the lines. Let me check what the textbook answer says. 6.6. Yeah, y plus x minus 3 equal to 0 and y plus x minus 3, y plus x plus 1 equal to 0. Both are correct answers.
Okay, sir.
So maybe we can stop here. We can continue if you are free. Then I think let me do at least. I'm at question number 10. Let me complete 11 also. 11 after 11 we will stop. Okay, 11th question we will do. All right.
Yes, sir.
So find the equation of a lines having slope. Find equation of lines having slope equal to 2 which are tangents to the curve, which are tangents to the curve y is equal to 1 divided by x minus 3. Similar question. So first one is dy by dx equal to minus 1 by x minus 3 whole square. How? Use u by du. Okay. So when you u by du, you get x minus 3 whole square. U dash is 0 minus u into v dash is 1. So that's how you get the answer, this one. So minus 1 by x minus 3 whole square. So this should be equal to 2, because the slope is equal to 2. So which means x minus 3 whole square equal to minus half. So that means square of something equal to negative. That's what this is saying. But that is impossible. It's impossible. So which means you don't have this condition satisfied. Therefore, absolutely no line, no lines will satisfy this condition. That means impossible. That's what is the answer. Okay. So,
Okay, sir.
it's an easy question. Let me check the answer as well. 6.3. Yeah, 11th question. No tangent to the curve which has a slope. So no lines will satisfy this condition also. That's done. Okay. So we can stop here for today. And so how is you are doing any maths at home?
Yes, I am doing.
Practicing now?
Yes, sir.
What and all, whatever I am doing this application of derivatives you are doing.
Yes, I am doing some problems.
Yeah. In the college, what they are covering right now in maths?
Sir, can you repeat again?
College, what they are doing? Which chapter they are doing?
Now they're doing revising inverse trigonometry.
Last time also you told me. I think this